Very good morning. This is Dr. A. Aravindan, Professor in Civil Engineering Department. Today we will discuss about the sustainable construction technology. This course code is 21CE 4156. This course under the cohort 8, that is the construction technology and management. Today we will discuss the Co1 topic, that is the construction methods for conventional frame structures. In this CO, 4 topic is there. First one is the conventional frame structure with the blockwork as infill wall. Then common building construction method for conventional walls and slabs. Next topic, types of foundation and construction methods. Then basic of formwork and staging. So these are the 4 topics under CO1. Today we discuss about the conventional building methods for the common building construction method for the conventional walls. So in this CO1 topic, mainly we will discuss the load bearing structure and characteristics of load bearing structure, advantage and disadvantage of load bearing structure, then what is the meaning of frame structure, then characteristics of frame structures, construction steps for conventional frame structure with a block wall and infill walls, then advantages and disadvantage of frame structures, load bearing, difference between the load bearing structure and the frame structure. Then we will discuss the different modern methods for the construction. So these are the various topics under the topic 1. First we will discuss the load bearing structures. Load bearing structure is nothing but it is probably the oldest and common type of the structures. These the load bearing structures in the loads of the roofs as well as lateral loads like earthquake, wind, etc. brought by the walls and through the walls, they are the transfer to lower floor and evenly to the foundations. It is known as wall bearing structures. In the pictures, these are the load bearing structures. In this roof load transfer to the wall only. So this wall transfer to the foundations. This is the load bearing structures. The next we will discuss the characteristics of load bearing structures. So the wall to act as the load bearing elements and are designed to resist the load applied to the, so the floor and the roof load are directly transferred to the walls and the wall distribute the loads to the foundations. So the load bearing walls are usually thicker and more massive to the handle the applied to the loads effectively. So interior walls often the opening for doors and windows, but these openings are very limited in the size and placement due to the load bearing structure nature of the walls. So the load bearing structure are often similar in the design but may limit the flexibility of interior layout changes. Next, benefits use the load bearing structures. So the performance and stability of the buildings are ensured by the load bearing structure or building, which is the structural systems where load of the structures such as the weight of the building itself and living loads are carried to the subsurface foundation through the walls. So the load bearing structure is the part of the building and securely transfer the load to the subsurface foundations. So the wall withstand the self weight of the structures, the load of roof and the load of the floor. The most beneficial application of load bearing structure is evident in the structural system and it serves a variety of purpose including sustaining load, separating of area, insulating the building from the heat and sound, etc. Then if you can break through the load bearing wall to 2 rooms, it since doing the some would endangers the stability of the buildings. So the enormous weight of the wall contribute the to hold the structures together, the stabilizing it against outside the factor like earthquake and wind. Next we will discuss disadvantage of load bearing structure. There are some drawback to the load bearing structures have limited their use in the construction industries like building It's with up to the 3 stories are best suited for the load bearing structures. Compared to other construction techniques, load-bearing masonry structure is require more hours and take larger to build. The masonry structure does not offer enough weatherproof thermal insulations. So the placement of walls cannot be changed after the construction has begun. So the masonry walls combined, the weight is heavy, and which ultimately makes the building heavier overall. So comparison to the frame structure, non-reinforced units are unable to withstand the high tension and shear stress, which result the poor resistance of masonry wall or poor performance against the earthquake load. Next we will discuss the frame structure. Frame structure is nothing but is a structure having the combination of structural components like beam, column, slab is connected together to resist the gravity and different lateral loads. So these structures are generally used to overcome the large forces, its moments to develop due to the applied loads. It is known as beam column structures. So the frame structure is consists of beam, column, slab. In the frame structures, the vertical load transfer the path is from slab or floor to beam, and beam to column, and column to load bearing footings, and then to soil. So the multi-story buildings, any height to be constructed. These buildings are usually designed for office building, hotel, residential, and apartment, and it contains mains vertical circulation in the form of stairs and lift occupying up to 20% of floor area. This image is the frame structures. You can see the frame is this is not supporting any walls. So the roof load carried to the beam load carried to the column, and column carried to the footing. Next, characteristic of frame structure. So the primary load carrying members like column and beam is bear the loads. So while the walls it serve the primarily to enclose the elements and may not be contribute the significant to the structural strength. So the frame structures it's provide more flexibility in interior layout. Since the walls are not load bearing and it can be placed more freely. So the use of frame systems allow the large opening in walls, facility architectural design, and their spacious interior and extensive glacis. So the frame structures often utilize the material like steel, reinforcement concrete, or timber for the main structural frame. So the framework transfer the load to the foundation through column, ensure the efficient load distribution. Next, construction steps for the conventional frame structure with the blockwork infill walls. So first, foundation construction. In the foundation, the construction is process typically begins with the excavation of the foundation trench, and footing are poured, and anchor bolt are embedded to the connect the columns. So the foundation walls are pier or construct to the support of the columns. Next, column and beam installations. So column are erected on the foundation footing or piers. So the beams are connected to the column and creating the skeleton frames work. So the reinforcement bar are placed within the column and beams to provide the strength. Next, slab formwork and pouring. So wooden or steel formwork is set up to create the mold of concrete slab. So the concrete is poured into the formwork and leveled. Once the concrete is cured in the form of solid slab. Next, block wall infill walls. So the infill walls are constructed between the column and the beams. So the masonry blocks are laid in the course and bonded with the mortars. So the opening of doors and windows are framed and created within the blockwork walls. Next, roof or upper level slab construction. If multiple floors are planned, this process is repeated for the each floor. It's creating the multi-story structures. So the slab for upper level are poured and reinforced as needed. Next, structural connection. So the proper connection between column, beam, slab elements are essential for structural stability. So the welding or bolting, it may be used as steel connections. Next, electrical and plumbing installation. So the electrical wiring, plumbing pipes and HVAC ductwork are installed within the walls and slab as per design. Next, finishing and cladding. So the interior and exterior finishes such as drywall, paint and cladding materials are applied to provide the desired appearance and functionality. Next, quality control and inspection. The various inspections are conducted to ensure compliance with the building codes and safety standards. Then final occupy. Once all construction and inspection are completed and the building is ready for the occupy. Next, we will discuss advantage of conventional frame structures. So first, versatility. So this method can accommodate various architecture designs and layouts. Next, durability. So the concrete and steel components offer long-term strength and stabilities. Next, cost efficiency. It can be cost-effective construction method for the mid-rise buildings. Next, we will discuss challenges and consideration for framework. First, construction time. So the conventional concrete method, it can be time consumed compared to the new method like modular constructions. Next, labor intensive. So it relieves the heavily on skilled labor for the masonry work and concrete pouring. Next, material waste. So some material waste may occur especially in block work constructions. Next, we will discuss the load bearing structure, comparison between load bearing structure and frame structures. In load bearing structures, the price is low, but frame structure cost is more. In load bearing structure, maximum up to 2 stories are suitable. In frame structure is increase the so many multi-story buildings. So the less space is used in the walls are thicker and floor surface is less. Then in load bearing structure, construction speed is very slow. Here frame structure is fast constructions. Then in load bearing structures, after the construction it is impossible to change any modifications. But in frame structure, when required the wall in position, it can be adjusted. Then the load bearing structure is taken deeper into the soil subsurface. But frame structures, only the column are inserted deeply and given the foundation footing. In load bearing structures, building is required additional labors. In frame structures, the frame structure need different ability. It is less labor intensive. Then even load bearing structures is several rules are not adequate in the structures. Life is not significantly affected. But in frame structures, if suitable technology is not used and standards or codes are not regularized as follows, the life of the building is lowered in the frame structures. Unlikely the frame structures, the load bearing structure may be built without the need for the costly equipment and plants. In frame buildings must be built with the expensive equipment and machineries. In load bearing structures, the wall must be constructed first since they support the slab and roof. But frame structure, the RC frame structure is often built first and it's follow the exterior and partition wall which increase the speed. So in load bearing structures, large span area are not feasible for the load bearing structures. The span is a restriction, that is room dimensions. In frame structure, the large span areas are achievable for the frame structures. Room size are not restricted for examples. Next, different modern methods for construction. So modern method construction is innovative and efficient construction techniques, and process is the aim to enhance the construction speed, quality, sustainability and cost effectiveness. So these methods often involve the off-site fabrication, automation and the use of advanced material. Here some different modern methods construction we will discuss. First one is the off-site construction. Off-site construction, it's involve the manufacturing or assembling building components in the control factory, its environment before the transporting and installing the on-site. So the prefabricated walls, floors, ceiling and even entire models can be constructed off-site and then assembled is quickly in on-site. It reduces the construction time. So on-site construction is improve the quality control, it's reduce the waste and minimize the disruption to the local communication. Next, modular construction. Modular construction is subset of the offset construction. It's entire models. It can be complete the rooms or sections of the buildings. It's manufactured off-site and then assembled together to create the final structure. So modular construction is allow the parallel processing of on-site and off-site work. It's leading to faster project completion. Next, volumetric construction. Volumetric construction is advanced form of modular construction where entire three-dimensional models include wall, floor and ceiling are fabricated by off-site. So these models are transported to the site and stacked or interconnected to create the building. Next, panelized construction. So panelized construction is involved the manufacturing building components like walls, roof panel in off-site and assemble them on-site to the form of complete structures. So the panelization offer the flexibility in design and it can accommodate the variety of architecture style. Next, precast construction. Concrete construction. So precast concrete is elements like beams, column, wall and slab are cast in the control factory environment and transport to the construction site for the assembly. So the precast construction is enhance the quality, accelerate construction and it reduce the need for the on-site form work. Next, 3D printing. 3D printing or additive manufacturing is used to create the building component layer by layer by using the material like concrete, polymer or metals. So these techniques, it can create the complex shapes and structure is very quickly with reduce the material waste. Next, digital design and building information model, that is the BIM. So the advanced digital tools such as building information modeling, it's enabled to the collaborate design and plannings. So the BIM is allowed the architects, engineers, contractor and other stakeholders to work together on the share the digital models, enhancing the coordination and reduce the errors. Next, prefab and kit homes. So the prefabricated homes, it involve the factory made building components that are assembled on site to create the complete houses. The kit home is provide the pre-cut and prefabricated materials that the homeowners it can assemble themselves. So are with minimal on-site labors. Next, cross laminated timbers. So the cross laminated timber is engineers wood product. It's made by the layering and gluing it's together the multiple layer of wood at the right angles. So the cross laminated timbers panel are lightweight and strong and it can be used for the wall, floor and roof. It's offering the sustainable alternative to the traditional construction material. Next, lean construction. So the lean construction is principle is focused on the minimizing waste and maximizing the efficiency and improving the productivity throughout the construction process. It involves the optimizing workflows, it reducing the non-value added activities and enhancing the collaboration among the project stakeholders. Thank you. Next topic we will discuss in next session. Thank you.